Welcome, engineers, to 3.1.4, part 1, and it's called while loops. So I'm going to talk to you today about a loop and how loops can make your life very easy inside of the coding world. What do we use loops for? What is the syntax of them? Like, do I use a semicolon? Do I use curly braces? How does all that work? Let's get going. Okay, so here I am over in Robot-C, and I've opened up a template, and you'll notice that I haven't named any of my motors yet inside, and maybe this will happen to you, and I want to show you a really cool little trick. You know how you have to go in to like the motors and you had to name everything? So like port 1 was like right motor, and you had to select what motor it was, right? There's a really cool, if you go to this tab on the far left, standard models. Believe it or not, this test bed that you built is a standard configuration. As long as you plugged all the things into the correct ports, if you select PoE and Sim test bed, if you click that, check it out. It auto-fills all of your things. And you're probably saying to yourself, why didn't you show us that at the very beginning? It's really important that you learn how to name your objects, because when you build your own robot, there's no standard form for that. So it's really important to know how to do it. But now that you know how to do it, I'll show you that's the shortcut if you ever need to do that again. So I'm just going to hit apply and pow. Look at it, automatically configured all of my stuff here. Okay, so up until this point, if I told you write a program that when you push the button, the bump switch, the motor starts up at half speed. And then when you let go of it, it's going to stop. Up until this point, we don't know anything that could do that. The best we could do is we could say until the bump switch is pushed, start the motor, left motor 50. Then we could wait 5 seconds, like some arbitrary number, and then we could stop our motor. So this is the best thing that we could do right now with what we know. And here's another cool trick. Like a lot of you guys, when you go to like send your code to you're doing like robot compile and download, if you just hit F5. So like if I just push F5, it automatically we've got some errors. What do I got here? Let's see if I can figure out what my errors are. It's expecting a semicolon in line 22. Oh, you know what? I bet I'm missing my parentheses around my 5. I'll hit F5 again. Yep, there we go. That was the bug. So now when I start this program, it's going to sit here waiting, and then when I push my button, you guys can't see. Whoop, here's my... Then the motor spins for 5 seconds, and then the motor stops. How could I build a program that every time I push a button, it only runs while All right, so here's the code. What this is doing. While 1 is equal to 1, double equals is a comparison. It's a question mark. Is 1 equal to 1 is always going to be equal to 1. So while 1 equals to 1, which is forever, I'm going to loop everything inside of these brackets right here. So I'm going to go to the smartboard. This bracket, it's going to continually loop from this bracket to this bracket forever. I'm never going to break out of that while loop. And that's why it's called a loop. Because I'm inside of those brackets. Now, I'm looping around, and now I'm waiting for another condition. So while I'm pushing the bump switch, and you have to put sensor value in there. That's something that I always forget. And you saw me, I had to look up the syntax. You have to use a square bracket around what you're trying to look for. So while the bump switch is equal to 1, now I'm going to start my motor. So I'm going to loop every time the button is pushed. While you're pushing the button down, I'm going to loop inside of those curly braces. So I'm starting the motor, and then I go back, and believe it or not, kids, what the computer's doing it runs through this loop probably 1,000,000 times a second. Like the computer is so fast, it's just always starting the motor, starting the motor, starting the motor. Well, I'm holding down the button, starting the motor, starting the motor, starting the motor, starting the motor. That's not a problem. It's not a big deal. You keep starting, it's going to run it at that speed of 80 the entire time. When the computer gets to the end, so it's reading this line by line. So if I'm pushing the bump switch, then it starts the motor. When it gets to this, it's going to loop back, check my condition, and then go back into it. Now, if I'm not pushing the bump switch, when it gets to the end of this line, it's going to go back, check the condition. If I'm not pushing the bump switch, then I jump out of this loop right here. So this loop that I was doing, I'm going to jump out of it and then stop the motor. Let's give it a try. Secret, F5. See if we get any errors. Oh, doesn't see any. And then we're going to start our program. I have an error. What is my error? Well, that's really a bump switch. Oh. I think I have to put my bracket right here. I gotta compile them down because I got some errors here. Oh yeah, look at here. In line 20. Yep, that was my error. So I'm gonna download that again. F5. This is what makes coding so difficult, kids, is that if you put one thing, oh yeah, that one made it through our, I still have an error there. So I click over here to compiler errors. Oh, so substituting, I was supposed to capitalize sensor value. So if I want to be really anal, capital S, and now I compile, hit F5, and it should take that error away. Simple errors, the compiler can tell you, I thought you meant this, so I just did it for you. And that's what a yellow is like, I think that I get what you're trying to do, but now look at, we are error-free. So we're going to start our program, and you can see nothing is happening on my board. Now when I push the button, the motor runs. And when I let go of the button, the motor stops. Now I wonder what happens if I do it again. Remember, we had while 1 equals 1. So it's looping inside of this. And you can see the green, I'm still looping. So if I do this again, it will still run. Push the button, let my finger off the button, push the button, let my finger off the button. So these while loops are really, really helpful, and they're really, really powerful. And you saw a couple things that I did. This is called a nested while. I have a while loop inside of a while loop. So I've got a loop inside of a loop. So I'm looping on this interior loop while I'm pushing the bump switch, but then I'm looping on this outer loop while 1 is equal to 1, so always. So this while 1 equals 1, if you want a program to run forever, like you just want it to continually be looking for a can to be dropped down into a can crusher, or you want it to continually be looking for, do you turn the knob to make the lights go up or down, or do you want it to continually be looking for the ambient light? If you want something to always be running, you have to start it with while 1 equals 1, or 2 equal 2, or 5 equal 5, or something that's always true. Set it up there. Let's go back and I'll give you a little more formal definition of all these things I've been doing here. So, while loops. And you saw how I used this while you have a condition, and my condition was while the button was pressed. You're going to repeat the commands. The three main parts is the word while, and the condition, and the command to be repeated. So while, the thing that you didn't see me do, we always have been putting, and you guys notice this on the 10 programs that you've done so far, you're always putting a semicolon at the end of everything. With a while loop, you totally don't do that. You do not put a semicolon at the end of a while loop. The commands that you execute, you definitely do though. Whatever I put here, remember how I started my motor? I put a semicolon behind that. But the while loop, big thing that took me a while to understand was that you don't put a semicolon there. The condition will control how many times a loop will repeat itself. And you saw that while the condition is true, it goes back and goes back into the loop. And so the condition is checked once every time through the loop. And remember, computers process very, very fast. So when you talk about overclocking, that's how much time it takes to execute one line of code. So you're going through this loop, checking it every single time. The command that you're going to execute goes inside. Boolean, you saw this word earlier. It's a yes or no answer. Like you saw mine, while 1 equal 1. That is true. Yes. While the sensor value bump switch equal 1. While I'm pushing the bump switch. Right? That's a check, a Boolean statement. And you can do all sorts of things Boolean-wise. You can say, is something equal to it? So we use equal to check, is it equal to it? And then 1, yes, that is true. 0 does not. That's false, always. You can use less than. You can use greater than. Here are some other ones. If you want to check, I want the motor to run while you're not pushing the button. So you could do a couple ways. You could say, while sensor value bump switch equals 0, because that's when it's not pushed. Or what you could do is while sensor value bump switch exclamation point equals 1, while it's not equal to 1. So this is another way. So you can get kind of creative in your code to kind of mimic what's going on in your brain. I want it to be when it's not pushed. So not exclamation point equal 1. That's because that's what pushed means. So we're learning a different language here, a programming language. So you can do less than or equal to, greater than or equal to. So it's got some what we call truth tables over here, and you can see they give 3 examples for each. So less than is 50 less than or equal to? That's true. But then when you go is 50 less than? That's false. So there's going to be certain times where you want it to, like if I want you to run something 10 times, are you starting the counter at 0? Because 0, 1, 2, 3, 4. Or are you starting the counter at 1? 1, 2, 3, 4. So if you want something to run a certain number of times, that less than or equal to is going to come and bite you. So we'll get to that later. And this will make more sense when I have you doing a program that runs exactly a certain number of times. Here's where I had to go back to figure out what the syntax was. Here's those square brackets. You have to make sure that you do things in very specific orders when you're doing this. So here's an example. While you're not pushing the bump switch and it's waiting, it's going to wait. An until function, the program hangs. So the program is not going to go anywhere until it gets dark. And then it's going to turn the flashlight on. And then the program is going to hang again until it gets lighter than 500. And then it's going to turn the flashlight off. So this is going to be an example of a night light, right? So when you're not pushing the button, look for it to get dark, and then look for it to get light, and then look for it to get dark, look for it to get light, and then when you push that switch, it jumps out of this. So this would be a really good code useful for people making lights along the street lights. You know, they pop on at dark, they turn off in the morning. This is exactly the code that runs that. In this code, the until, it says a motor is running until an object is within 50 centimeters. The program can't respond to an emergency shutoff switch. The program is going to hang right here until. It's not checking anything else. So these until things, nobody uses until in the coding world. Big boy and big girl coders, they don't use until. Like, we use whiles. Those are way more powerful than an until. They're good to teach you a little bit about coding and how it goes line by line, but now we're going to get into decisions, and that's really quite powerful inside of coding. Here's an example doing that exact same thing. This program here and this program here are exactly the same, except now we can look to see if we push a button like an emergency stop. So you could say while the sensor value push button equal 1. So now you can be checking. So this program is still running. The sonar value, as long as it's greater than 50, you're going to execute everything inside of here. But now you can be checking to see if they pushed an emergency cutoff switch. So putting things inside, very, very helpful. I think they actually do it here. Let's see, what does this do? Start our motor, left motor, full speed, while the sonar is greater than 50. So as long as everything is more than half a meter in front of it, keep running itself forward. So, oh, look at here. They're adding in something. Ooh, this is cool. Starting the motor. So you remember how the motor, we set the motor to a speed up here? Look at the speed that they're setting their motor equal to. They're setting it equal to whatever the potentiometer is divided by 400. Because remember, like when you turn the potentiometer all the way up, it was like 4,000. So now, when you divide by 400, if you have it cranked all the way to the right, your right motor is going to be at 100. And when you have the motor all the way to the left, it's going to be equal to 0. So this is a really cool way to set your motor speed to whatever the potentiometer is. So you have a variable speed motor. That's kind of fun. And this and you'll see this thing right here. If you want two things to happen, as long as something is more than 50 centimeters away and less than 70. So maybe, I don't know if you guys haven't been on a golf course, but they make golf bags right now that will follow you. They have sonar on there, or they check, like you have a little receiver you put in your pocket, and when I walk away, it follows me at a certain distance. So as long as I'm more than half a meter away, but not less than set, so it stays a set distance from me. So if I'm more than 50 and less than 70, let's go. Stay there. So this is kind of a really interesting way to check two things at once. All right, this is where I'm going to end today. You guys got a really good introduction to while loops. How important that they are. They're probably one of the most fundamentally important things inside of coding, this while loop. Now remember, big ideas. Don't put a semicolon behind it. Do indenting, like this indentation I did here, because it's going to be really important for you to understand where these loops are. So you can indent so that I can understand that this is a loop right here. This is a loop right there. All right, good luck, kids, and we'll see you next time.